Hi, and welcome to This Is My Architecture. I'm Dave, and I'm here with Gene from ProtectWise. Gene, what do you guys do?
ProtectWise is a high-scale network security company, and what we're doing is we're shifting core network security functionality from the traditional enterprise to the cloud.
Okay, I love the cloud, so you guys are probably ingesting a lot of data, right?
We do. So the crazy thing that we do is we do packet capture at a really fantastic scale. And so we give our customers a lightweight software sensor. It captures packets on their traditional enterprise network, inside their cloud, like their AWS environment, as well as industrial systems, and it ships it to our cloud, which runs in AWS.
Okay, cool. And you guys do that at Full-Fidelity?
We do. We keep those packets. So we like the raw bits and the bytes that transact over the wire because we're going to use them to reconvict them later.
Okay, show me how you do it. I'm super excited.
Okay, so it is a lot of data in motion. So when I talk about packets, and we're mostly focused on large enterprise, this is gigabits of data per second. And what it does is it exits the network. It happens in real time. It's compressed, optimized, shipped to the cloud, to our ingest service, which runs inside of AWS. And the first thing that happens once it joins our ingest service, it goes through this process that we call destructuring. And what destructuring is a process whereby we break that raw data down into constituent components that are purpose-built for very specific forms of analysis.
So like chemicals in a solution, right?
Very much like that. So you can think of all the tuples that are in there, all the features you want to extract because you want to analyze them.
Right. Okay, great. So now we've destructured it. What are we going to do next?
We're going to try to make some use of it.
We're going to do a lot of stuff,
So the first thing we're going to do, exactly, is we're going to send this data basically into this time machine for threat detection. So we have this time machine, which is executing in this version of it, a very much real-time and analytic approach. So something happens locally on the network, milliseconds network latency later, it is hitting this time machine and is being run through the suite of threat detection capabilities. It is also being fed directly to our visualizer. So this is a set of APIs, but also a really beautiful visualization experience.
And people want to see that visualization pretty quick, right?
Security is really important. It's very time sensitive. So something happens here, network latency later, it's visible here. It has possibly also been convicted.
So tens of milliseconds, that's solid. Yeah, so what happens next?
So what we want to do is that even though we're percolating the stuff in real time, the most interesting things in security are not the real-time things. They're the things that have already happened. Those are the things that are top of mind. So the time machine is also needing to go back in time to discover the previously unknown. And so toward that end, what we have built is a meta-index data API layer that we call Quero. And what Quero does is it is able to take algebraic data types and pushes them into Cassandra and Solar, which for us is DataStax Enterprise, that takes the hot edge of all those writes happening as the network is humming and throbbing, and is pushing them into an SSD cluster. This is really high performance. It's also a little expensive, but this data is also then being joined into this EBS-based Cassandra and Solar cluster, which is a little bit more affordable, but that's for data that has moved on in time and has gone past the right edge. But also, we are then doing this. We're pushing data into Parquet, which lives inside of S3. So this is basically a file format that's columnar, very well optimized for really good seek rates inside of S3. Because at the end of the day, with this volume of data, we are discussing a system that generates petabytes of indexes because our standard offering of retention is a year. We want to go back a year to discover the previously unknown.
So dollar sign, dollar sign,
yeah,
dollar, right?
That's exactly right.
What kind of instances are we using here?
So these are I2 instances here running on the SSD. So that's directly attached SSD. Very great I/O, really kind of expensive in a way. The EBS is a lot more affordable. That makes a lot more sense. It's what most people are used to. And then we can take a stateless infrastructure approach and use EBS trickery and EC2 trickery. It's actually just native features, whereby we can collapse and eradicate entire clusters of data as the data is being moved into S3. So as this data goes from hot to warm, from warm to cold, but by cold, I still mean a system that's going to satisfy real-time as well as retrospective analytics in a sub-second manner.
And we're not using replication because that would just fall over, right?
There's too much data to replicate in a traditional way, so what you're going to use AWS for is making afternoons and of work that would normally take weeks in order to accomplish. And in our use case, replication would never even finish.
Okay, great. And then we've got a packet lake down here. What's going on here?
We do. So one of the neat things that's happening here is that this is the index that sits in front of the actual system of record down here. And so this really just helps us interact with this in an efficient manner. So as data is being ingested, it is actually also being brought down into this huge data lake. And this is the raw bits and bytes that have been laid out inside of S3 so that we can go, with the help of the index, lift up the raw network transactions and rewind the tape and actually fast forward, rewind, go back and forth. And as threat intelligence advances, as we discover new attacks, we go back in time to discover the previously unknown, because we can look for something that nobody knew how to look for before.
So no packet left behind,
right?
No
packet left behind.
Well, that's awesome, Gene. I really love what you guys have done here. Very cool system, very big, very fast. Thanks for coming out, and thanks for watching. This is my architecture.